Okay, it is now time to complete our travel log about the plate tectonic story going on in Hawaii that has created this island chain of volcanic mountains. And here's what we already know. We know that they're full of lava flows, but we don't know what's causing that. And so we've been to three places already. California was a slide-by transform boundary where the plate sliding created fault lines like the San Andreas Fault to cause earthquakes. In Iceland, there was seafloor spreading at the mid-ocean ridge because the plates were pulling away, that's divergent, and magma will come out and cool into new crust and chisel or push the old away. Then our third spot, Nepal, we learned that convergent means push. But we also learned that it mattered what kind of push, what kind of crust was pushing. And in Nepal, continental crust on one side is hitting continental crust on the other plate. And because of that, you have the same density, nothing sinks, and you get mountains. So Nepal is a continental convergent plate boundary. So what's the story then with the plate boundary in Hawaii? And so you should be now to your travel log. And remember that travel log is on a separate Google Slides, and this would be the third slide on that. So you might need to pause me and get to that. But here is the plate boundary story, and this might be shocking to you. Get ready. None. Hawaii is a rare case. About 90% of the world's volcanoes do occur on plate boundaries, but Hawaii is in that 10% or so where it is in the middle of a plate. So what is the story then? Like right now, we're in the middle of a plate, but we here in Ohio, but in the middle of the North America plate, but we don't have magma that's flowing up here. So I really like this kind of rhyming term. Hawaii has formed as a tectonic plate moved over a hot spot. And so the key thing here is that you underline hot spot. And notice this, not multiple tectonic plates, as a tectonic plate, one plate, the Pacific plate, moved over a hot spot. This is not a plate boundary. Now we're going to watch a quick video of it, and then I'm going to explain a little better. So check this out.
A hotspot is a particularly hot part of the mantle that causes rocks to melt, producing magma. The magma rises up through the crust and forms a volcano. As the plate moves, the volcano is carried away from the hotspot and becomes inactive. A new volcano can now form above the hotspot. Over millions of years, a long chain of volcanoes can form. The oldest volcanoes in the chain are located furthest from the hotspot. The Hawaiian Islands are an example of a volcanic island chain created by a hotspot. The active volcano of Kilauea is currently located above the hotspot, and a long chain of extinct volcanoes stretches out in the direction that the plate is moving.
Okay, so I want to go back a second.
Volcanoes
and pause it on a spot.
Above the hotspot.
Okay, so do you know, go away. I'm not talking to you. My students, I'm talking to that little blurb. Okay, so do you notice this part that's orange? That would be the jelly-like asthenosphere. And we know that tectonic plates are floating. Remember that part of the song? Plates floating on the asthenosphere. So you notice here the movement is this way. It is only one plate moving over the hot spot. Now, does the hot spot move? So if we keep forwarding ahead,
the Hawaiian Islands.
Do you notice that the hot spot itself is not moving? It is just the tectonic plate that is doing so. Now, here's a still version of it that I wanted you to check out. Sometimes when students see this and it says fixed hotspot, they think like fix, to repair it. That means it stays in place. And then you can see here's the asthenosphere with the lithosphere, also known as the Pacific plate in this case, moving over it. Hawaii is not at a plate boundary. Okay, our final step in Hawaii is going to be to analyze a picture of the Waimea Canyon and relate it to the age of the different islands in Hawaii.